Hello and welcome to our second topic in this mathematics series, and here we are going to deal with indices. So what do indices mean? First of all, indices is the plural form for index. Index. So what is an index? An index means a power. An index is a power. So indices is just like saying powers. Alright, so what are these powers? What are we talking about? So powers are just telling us how many times we are going to multiply a particular number. So this indices is going to deal with how we are going to multiply numbers to so amount. So we say 3 raised to power 4 or 5 raised to power 7, meaning 5 times 5 times 5 in 7 places. Or we say x raised to power y or x raised to power 3. Or we might also have negative powers, negative indices. So that's what we are going to be dealing with. And this topic is very much important, not necessarily in mathematics, but since mathematics is applied in various subjects like chemistry, physics, engineering, so it's going to be very important for us to have a very good grasp of this topic. And here's the outline. What we are going to learn by the end of this topic. We are going to learn standard forms. Standard forms is just like expressing numbers in indices, maybe in power forms. So we are going to learn standard forms, then the laws of indices, because indices will have how we are going to deal with them in particular circumstances or particular situations. Then after that, when we have a very good understanding of the standard forms and the laws of indices, then we can apply what we've known in these two into solving equations. And it's also going to be an interesting ride, so hang on. So standard forms, and why do we need them? Let's start with standard forms. We said our first, in the outline we said our first topic or subtopic is going to be on standard forms, and here we are going to deal with why we need them. First of all, we need them for measuring large distances. Well, if you are in your living room now watching this video, then maybe your distance or how far your kitchen is from you might be small or might be large, but whatever it is not as large as when we are dealing with your distance or our distance here on earth to our distance to the stars. Let's say from here to the moon is very far, from here to the star is far beyond our imagination, because we are measuring that distance in light years. So when we begin to measure those distances, we cannot use normal numbers and see it's million. It becomes tiring. So this time around we begin to use them in power forms. So that's why we need standard forms. Then we can also measure sizes. Sizes of microorganisms are very small. So instead of using them with normal numbers and saying times 10 raised to power or times or saying the size of something is 0.0000000 so amount, we just say okay, so this thing is as its sizes times 10 raised to power minus this, or its micrometer or centimeter. So we've just made it easier for ourselves to give the sizes of objects or organisms. So that's it. But there are other reasons why we need these standard forms, but I'm just restricting myself to these two so that I don't take much of your time. And then in standard forms we have whole numbers, because numbers we might have numbers that are whole numbers, and we might have other numbers that are decimals. So when we have whole numbers, like let's say 2, 1, 5, so when we want to convert those numbers, a number like this one that is a whole number, to a standard form, we move in the left direction, meaning we move in the left direction, and when we do so we are going to have a positive power. So this is what I mean. So supposing we want to express 215 in standard form, so we are going to start from here and jump 1 and 2. The moment we reach a number, we don't move to this point. The moment we reach this point, before we move to the last number, we stop, and we see, since we will move to the left, so we say 2.15 times 10 raised to power. How many times did we move? We moved one time, two times. So we moved times 10 raised to power 2. But this direction, since we moved to the left, we say we are going to have a positive power. So positive power meaning we are going to write plus 2. But then, since it's a positive, we don't have to write the plus. So you can just write it as 2.15 times 10 raised to power 2. Very simple. But what if we have decimals? So when we have decimals, that's when we are going to use this right movement. So let's say we have 0.000215. So what we are going to do is we are going to move to the right. We are going to start 1, 2, 3, and 4. We are going to stop here. We don't move to this one or this one. But if you like, you can do that. But for expressing numbers in standard forms, this is the best way to do it. To stop immediately when you reach a number. This one too, we stop immediately before we reach the last number. So this one, 1, 2, 3, 4. So we see 2.15 times 10 raised to power. How many times did we move? 1 time, 2 times, 3 times, and 4 times. So we moved 4 times. But in what direction? We moved in right direction. So we are going to write a negative. So it's going to be a negative power. Positive power because we moved to the left, and negative power because we moved to the right. Don't worry if you don't get this one fully, but we are going to take a lot of examples. So hang on. So these are the examples. The first one, the example says express the following numbers in standard form. So we have the first one which says 2540. Express it in standard form. Since it's a whole number, that's the first thing we need to do. Check if it's a whole number. Does it have a decimal point? No, it doesn't. So it's a whole number. So we move from the left to the right. 1, 2, 3. We move and stop before we reach the last number. So we moved 1, 2, 3 times. So we are going to write it 2.54 times 0 if you like. If you like, you can write the 0 if you like. There is no problem. 2.540 times 10 raised to power. How many times did we move? 1, 2, 3. We moved 3 times. So we are going to write it 3 times. Did we move to the left or to the right? We moved to the left. So it's going to be a positive power. So it's going to be a plus. We don't even have to write the plus. So it's going to be a positive power. So our answer is 2.540 times 10 raised to power 3. Very simple. Then the second one says 1, 2, 3, 7, 2. This is the one we are dealing with. We've dealt with this one, and this is the second one. So the second one says 1, 2, 3, 7, 2. I'm guessing by now you should be able to do this yourself. Well then, so it's a whole number, right? So we move from the left to the right. 1, 2, 3, 4. So we drop our point here before we reach the last number. So 1.2372 times 10 raised to power. How many times did we move? We moved 1, 2, 3, 4. We moved 4 times. So we are going to write it 4. Did we move to the left or to the right? We moved to the left, and we said if we move to the left, it's going to be positive. So we don't have to write the plus here. So our answer is 1.2372 times 10 raised to power 4. So that's it. But there is something I want you to take note. It doesn't matter where you stopped. It doesn't matter. It's not compulsory for you to stop at the last number. You can stop here. So supposing we have 2540, if you stopped here, it's still okay. But for standard forms and for exam purposes, we need to stop at the last number. But then if you stopped here, then you know that you are not going to write this 3. You are going to write the number of times you stopped, the number of times you skipped numbers. So the number of times you jumped only once. So you're going to write times 10 raised to power 1, and it's going to be 245.0, something like that. 245.0 times 10 raised to power 1. So that's it. Very simple. So you need to be sure of how many times you jumped. So the number of times you jumped is going to determine what you write on the power. So now we are going to move into the 0.065. So 0.065 says we have a decimal number. This this is a decimal number, so it has a decimal point, so we are going to move to the right. So 0.065, we are going to move to the right. 1 and 2, we stop at where we have before we reach the last number, where we have the first number, not when we have this. We skip all the zeros. When we skip all the zeros, the first time we have a number, a full number that is not a zero, that's where we stop. So we have 6.5. So 6.5 times 10 raised to power what? How many times did we move? We moved 1, 2, we moved twice, but then we moved to the right. Since we moved to the right, we say we are going to write in negative. So our answer is 6.5 times 10 raised to power minus 2. Very simple. Then for this one, I'm guessing by now you should be able to do it. 0.00043. So what do we do? How many times do we jump? We jump 1, 2, 3, and 4. Immediately when we reach a number that is not 0, that's when we stop. So it's going to be now 4.3 times, how many times did we move? 1, 2, 3, 4. We moved 4 times, so it's going to be times 10 raised to power 4. But then we moved to the right, so it's going to be a minus. So 4.3 times 10 raised to power minus 4. So the last thing I want you to take notice, we have a negative here and we have a positive here. So which one is bigger? Any number that is positive is the one that is bigger. So this one is smaller than this one. This one is bigger than this one. The ones that have the positive power are bigger than the ones that have negative powers. So that's it. Very, very simple. So we are going to take more examples. We are going to even take quizzes. But for now, we are going to stop here.